to my YouTube channel, amazing people, and all the lovers of chemistry out there. This is David, and this is the hub where we take the concepts of science from complex down to simple. Now, we started a series recently on the concept of balancing chemical equations, and we're taking it one step at a time. And on today's episode, we're going to be looking at the foundations of chemical equations. So let's get into what we have for today's video. First things first, we're defining what a chemical equation is. So a chemical equation is like a story. Okay, now most of you, or all of you, let me assume, love to listen to stories. And the interesting thing about stories is that they tell you what happened, whether it happened in a real life scenario or it's purely fictitious. Alright, so a chemical equation is like that story. It tells us what happens when substances that are called reactants come together and change into new substances. Those new substances are now called products. I'm sure you're following every bit of what we're doing in today's lesson. Now, in stories that we tell, we use long sentences. Those sentences come together to form paragraphs. And those paragraphs come together to form chapters. And those chapters come together to form the entire story. But in chemistry, we tell our stories using chemical equations that use symbols and formulas. Okay, so we're going to be getting into the concept where we see what symbols mean and we see what formulas mean as well. Alright, so here is an example of what a chemical equation looks like. You can see on the screen right now at the bottom left corner, I have an illustration that shows reactants A plus B, A and B coming together to form a new product AB. Now you can see from the previous video we talked about the process whereby a chemical reaction happens and no new substances magically appear. We started with two substances A and B, and we are ending with two substances as well, A and B. So this is the chemical equation. It is telling us that we started with two reactants A and B, and we ended with two reactants A and B as well. So now that we have that out of the way, let's move on to the next concepts that we want to deal with. There are two ways that you can represent a chemical equation, okay? The first way is the word equation format, and then the second way is the symbol equation format. Alright, now the first one, which is called the word equation format, is a process where you write a chemical equation using the names of the substances. Now, when you do this, you write the names of the reactants and the products in full. For instance, you have this example over here that says hydrogen reacting with oxygen to form water. The names of every participant in this chemical reaction is fully written. Okay, so this tells us what is reacting and what is being formed. It is easy to understand, straight to the point, but it is not very precise in the sense that it doesn't tell us how much of the reactants are being combined together to form the amount of product that is gotten. So that brings us to the next way to which we can write a chemical equation. That is the symbol equation. Now, this is where we use chemical formulas and symbols instead of words, and that's what we're going to be doing for the rest of this series. So we have this example on the screen right now. Instead of saying hydrogen plus oxygen to give us water, we simply used the symbols. So instead of saying hydrogen, we simply use the symbol H2 plus oxygen, which is O2, to give us water, which is H2O. Now this one is much shorter and clearer because number one, it shows us the exact elements that are involved. It shows us the number of atoms of each element that participate in this reaction, and then it shows us the chemical structure of these substances, which is why we use symbols and formulas to write chemical equations in chemistry. But here's the deal. This equation is not yet balanced, okay? So when we get to the concept of balancing chemical equations properly, I will show you what to do. But just know it for a fact that we use symbols and formulas whenever we're writing chemical equations in chemistry. Now, here is a real life analogy of what a chemical equation is. You can relate it to the concept of ingredients and recipes. Okay, so now think of a chemical equation as a recipe in the kitchen. When a recipe is placed in the kitchen, a recipe is simply a collection of information that tells you the kind of ingredients you are to add together to form a particular type of meal or dish. So those ingredients that you combine together in the kitchen, they are your reactants, because they are the ones that come together to form the final dish that you want to prepare. The product is your finished meal, and then the equation is your cooking guide. So if I want to treat cooking using a recipe like a chemical reaction, I would say your recipe over here is your chemical equation. Why would I call it your chemical equation? I would say it's a chemical equation because it is the one that tells us what and what is being combined to form the final product, which is this plate of meal over here. I'm sure you're understanding every bit of what we're doing right now. So now, just like you need the right quantity of rice, pepper, and seasoning to make jollof rice, in chemistry you need the right quantity of atoms and molecules for a reaction to work properly. Now, this recipe that I made reference to moments ago, I told you that it tells us the ingredients that we need to combine together to make a meal. Not only does it tell us the ingredients we need to combine together, it also tells us the amount of ingredients that we need to combine together. For instance, it tells us that we don't just need to add rice, we need to add 2 cups of rice. In the same way, a chemical equation tells us not just the elements that are reacting, but also the amount of the elements that are reacting, so that we can get at a definite answer. I'm sure you're enjoying every bit of this lesson. So for example, you have this cooking recipe on the screen right now that says you need to add 2 cups of rice, 3 cups of water, 1 cup of tomato sauce. Just an example to make delicious jollof rice. So if you are to use the chemical equation style, the word format, you would simply say sodium plus chlorine will give us sodium chloride. Now, there is a chemical equation for the production of sodium chloride, which we call table salt or common salt. You can write this in 2 ways. You can say sodium plus chlorine gives us sodium chloride. But you see, this doesn't tell us the amount of sodium chloride that is formed. This doesn't tell us the amount of chlorine we need. And this doesn't tell us the amount of sodium that we need. But when you use chemical equations using symbols and formulas, this tells us that we have sodium Na plus chlorine Cl₂, giving us sodium chloride. Now, this format is much more clearer and concise, because this tells us that we have 1 atom of sodium, and this tells us that we have 2 atoms of chlorine, and then over here we have 1 molecule of sodium chloride. So that is more detailed and more precise. But wait, that symbol equation isn't balanced too. Okay, so we're going to learn how to balance them. I'm just showing you the basics of everything you need to be acquainted with as far as chemical equations are concerned. So the summary of all we've been saying since the commencement of this video is this. First things first, chemical equations show what happened in a chemical reaction, and we can write them using words or we can use symbols, and then they are just like recipes. They tell us the ingredients that go in and the final product that comes out. Understanding how to read and write chemical equations is the first step to mastering chemistry. I'm sure you enjoyed every bit of this that showed us the foundation of chemical equations. Up next, we're going to be looking at the law of the conservation of mass. We're moving gradually and we're making progress steadily. I will see you in the next video. Up until then, my name is David, and all I do here is to take the mystery out of chemistry so you can make history. I'll see you in the next video.